Welcome to MLOps Live, a podcast by Neptune AI.
We host in-depth discussions where machine learning practitioners answer questions from other practitioners about one subject related to production machine learning and MLOps.
Tune in to get real-life stories, dirty hacks, and pragmatic workarounds from ML people in the trenches. Welcome to the show. We are back with another episode of MLOps Live. So I'm Sabine, your host, joined by co-host Steven. This is an interactive Q&A session, as always, with our guest today, Danny Leybzon. Danny is an MLOps architect at Y Labs at the moment. He has an educational background in statistics and political science, and he has professional experience in data science as a solutions architect and a senior field engineer. So, Danny, welcome to the show. Anything further you'd like to add to your introduction?
No, I think that was a great introduction. And Selena, I'm shocked at how well you pronounced my last name without having to ask me how to pronounce it. That's such a rare occurrence.
Well, thank you. I may have done a little bit of research on that one. So
Good.
All right. So just to warm you up here a little bit, how would you, to our guests, explain ML observability in 1 minute?
Good question. I don't think that I even need a full minute to explain what ML observability is, but you can start the timer. So ML observability is the ability to view the entirety of a machine learning system in order to root cause and debug issues in that machine learning system. I don't know, what was that, like 10, 15 seconds, right? That's the basic overview. Yeah.
Succinct, concise. We're happy.
Thanks, Danny, for that succinct introduction, I would say, with just giving us that very concise definition of ML observability. And we have some premeditated, questions from both from the community and as well as some of the ones we sourced. And I think one of the crucial ones we need to get started is with, which is very, very crucial for reasonable skill teams to think about, is when is the best time to start thinking about ML observability in your opinion?
Yesterday, like in terms of the model development lifecycle, I would say that you have to have observability when you deploy a machine learning model, and then you need to start thinking about it ahead of time, right? Because you need to think about how you're going to be instrumenting, how you're going to be getting to machine learning observability before you deploy the model into production.
Because usually when some teams talk about this thing, they feel like you need to have observability both in like your training phase, detecting root causes and like training failures, as well as production phase. And in most cases, when you hear MLOps observability, you hear everything post deployment. So it's very crucial. We need to understand when to start thinking about data in that case. Awesome. So I would love to ask again, how should I model my monitoring and observability system for any ML project I'm doing? Are there strategies I need to know? Because if we look at the software engineering space, there are mostly strategies you use for like your DevOps monitoring, right? Whether it's your integration monitoring systems or things like that. But in the MLOps space, since it's nascent, things like this have to be consider, because like diverse use cases, right? And so how would you think that, how would you expect that, how would you recommend that a team think about modeling their observability system whenever you're working on ML projects?
How to model it, like how to create the solution for it?
Yeah, kind of how to think about it, how to think about building the observability system into their projects. Yeah.
Absolutely. So I would say, to me, the top priorities for an observability system are that they need to give you continuous monitoring. So you need to be able to constantly keep track and detect any kind of changes in the system. it needs to be complete. So it
Right.
needs to give you a view of the entire system. A lot of people really focus on monitoring the model, and we can totally dive deeper into that with, like data drift detection and model performance degradation detection. But ultimately, in order to do the kind of root causing that we're talking about, in order to really debug problems with machine learning systems, you need to look not only at the model, but at the system as a whole, which means like the entire data pipeline before it even hits the model. So I would say
Right.
that those are two really big considerations to make when thinking about how you're going to be instrumenting and tooling your observability solution for your machine learning models in prod.
Right. Awesome. And then, one of the biggest pushbacks I would say with the whole MLOps space is that vendors are like building tools for like the 1% of the people, right, or the 2% of the people solving problems. And with ML, there are like different use cases. You're solving computer vision use cases, NLP use cases, classification use cases. However, so how do you start building a system that works across these different use cases as a reasonable scale team? So we're like 4 data scientists, or maybe 2 data scientists and 1 software engineer. We're deploying like 10, 15 models, or probably even lesser than that. How do we start building a system that integrates these different use cases, ranging from like computer vision to machine translation and everything, into one system that we can have good oversight on for the entire project?
Yeah, it's a great question, and I'm trying to figure out how to answer your question while avoiding just like directly selling my product. But I honestly think that like for a small team that's dealing with, especially like you're saying, a diversity of use cases, having a single pane of glass where you can monitor all of your models and where you can see the performance of all of those models, and importantly, you can use the same UI to do debugging is really important. And one of the things that really stands out to me about Y Labs in particular as an observability and monitoring solution is the self-serve capabilities. The fact that like to try out and to use Y Labs in production, you never need to talk to anybody on the team. You can just go on our website, start using the product. It's $50 per model per month, which is a lot cheaper than hiring a machine learning engineer or a data scientist. And it scales really easily from the smallest team to the largest team. So yeah, I would say, if you're open to a vendor-based solution, then I think going with like an easy to deploy self-serve tool is really low-hanging fruit and a very lightweight way to get a lot of lift. The other option that I would say is, regardless of what type of model that you have, the majority of use cases are on supervised learning, right? Like you're either doing classification or regression, whether it's like an NLP model or a computer vision model or a tabular model, you're usually going to be doing some kind of supervised learning in production. And with that in mind, you can kind of treat these models, you can abstract these models and find the commonalities between them. So, all models effectively are a form of data transformation. You take some input data and you produce an end result. You produce like a prediction. So you can monitor that input data and you can detect data drift, data quality issues, all of those. And then you can also watch for changes in the output. And even if you don't have ground truth, even if you don't, know the actual performance of your model because you're not able to check the predictions against the real world, just watching for changes on the input data and on the output data can be pretty easy to do. Yeah.
And just before we go into the community, we have some other questions I think that are specific to some of these metrics we should be sort of monitoring. I think beyond model evaluation, all those things like, like you said, it's mostly supervised learning problems we're looking out for. We're looking at accuracy, we're looking at maybe like your confusion matrix or things like that. Or those sort of evaluation metrics. I think in the DevOps world, there are also other metrics we look out for, like, the system metrics. What's the case with ML, like ML observability? Beyond just that model evaluation, what are some other metrics we should kind of look out for or consider when thinking about observability?
Absolutely. And I'm really glad you keep bringing it back to like the traditional DevOps and software 1.0 observability, because I honestly think a lot of MLOps is just catching up with things that DevOps has known forever, right? Like DevOps has known for years that in order to be able to do observability, the three pillars of observability are traces, metrics, and logs. And this is really something that we're just starting to catch up with on the MLOps side. But I think there are some important distinctions between the problems that we solve in MLOps and the traditional DevOps problems, because I think the problems that we're solving with MLOps are actually a superset of the problems in DevOps. Like for DevOps, you want to know, is my system up? What's the response rate? What's the response time? Am I hitting my SLAs? Obviously, we care about all of those things with a machine learning model, right? Like my machine learning model is making its predictions slowly. My Netflix won't load. My Uber won't be able to tell me what an ETA is. Like it needs to be up, and we need to be able to do application performance monitoring in the classic like observability sense. But the difference is machine learning models are also, I don't want to say non-deterministic, but they have a greater degree of dynamicism in them because they're fundamentally relying on processes from the real world that are constantly shifting and changing. So with that in mind, when doing machine learning monitoring, in addition to the problems that you need to solve in DevOps, like, is my machine learning model still making predictions? You also want to know, is it making good predictions? And that requires tracking metrics like, is my input data drifting? Is my F1 is my F1 score going down? All of these different things. And honestly, like as an industry, we're still kind of coming to like conclusions as a group about what is it that we need to be monitoring for all of these different types of models.
Yeah, that's awesome. I think we have a question from the community.
We do have a question in chat, sort of fundamental question. What is the difference between observability and monitoring?
Yeah, great question. And honestly, one that like there could be PhD philosophy thesis books written about because this is like such a topic of conversation that we have all the time. To me, and when I talk about observability and monitoring is a continuous system that lets you know when there is a problem. Observability is a human in the loop root cause analysis system that allows you to determine what the problem is in order to solve it. So like, this is a little bit abstract. Let's be more specific. I've got a machine learning model in prod. It's chugging along, making predictions, whatever. So I've got both monitoring and observability set up on it, maybe with Y Labs, maybe with our open source Y Logs, maybe with something that I've built out myself. Now, my monitoring will tell me, hey, Danny, you have a big spike in the number of nulls all of a sudden in your input data. And as a result, your predictions are not as good as they used to be. Okay, this is really useful information, right? This is great. But now I need to go into my observability solution, into my platform. And after, in response to this monitoring alert, I need to be able to debug and root cause analysis. Why are there a bunch of nulls? And find out, oh, it turns out that somebody pushed a bad version of a data pipeline. There's like a bug in the code. And as a result, like a typo. And as a result, there's a bunch of nulls coming out. Okay, this is great to know. Now I can go back and I can solve this problem. So you can see how like monitoring and observability are kind of, they work hand in hand in order to solve problems. Where monitoring tells you that there is a problem, observability tells you how to solve that problem.
Great. Thanks, Danny. And thank you, Mustafa, for your question.
And that's awesome. And it actually leads me to a really crucial question, and which is something I think, again, in the DevOps space is always a concern, and even really a concern in both like the data observability space as well as the ML space. And that's the alert hell, in quotes. What does the alert hell look like, in ML observability, and how can teams navigate it? Because I think that's one crucial thing that teams face whenever they start thinking about observability. What should I monitor? There are lots of things to monitor, right? You're logging everything, and then what should you think of? And then when you think about things to monitor, what should you set alerts for? Not just, false positives and things like that. How should teams think about this in this sense? How should they select the things that are crucial for them?
Yeah, it's a great question. And I mean, honestly, there is no like perfect answer, right? Because the answer is it depends. Like it depends on your model, it depends on your environment, it depends on your team, it depends on all of these different variables. I would say that the impact of that means that you want to pick a tool or pick an approach that is both opinionated, so it has like out of the box ideas, so that you don't have to do all of the heavy lifting of figuring out, these are all the things that I should monitor, but also flexibility, right? It should be opinionated, but also customizable, so that you can pick the particular metrics or the particular things that you want to be tracking. I would say like some table stakes things to track that everybody should track and monitor and observe on would be performance if you have access to ground truth. I mean, that's ultimately like the holy grail. That's like the perfect thing to be monitoring, because it's literally telling you how good is your machine learning model. A lot of the time teams don't have access to that, so there's plenty of other things to monitor. I would say input data drift is a really powerful thing to monitor. And the complexity there is, how do you quantify data drift and how do you measure it and what metrics do you use for it? I can dive into, for a number of reasons, why we think Hellinger distance is the best metric for calculating data drift. But basically, like, some metric for calculating the possibility of the fact that the real world is changing, making your model stale. And then the last thing is, you should be measuring for data quality. Data quality means like a bunch of different things in a bunch of different scenarios. In at Y logs, we monitor for the number of nulls, cardinality changes, so like the number of distinct values changing in a column, schema changes in the incoming data, all of these things that would indicate, there's something going on with my data that's not a data drift issue, but an issue with, some tooling that's happening upstream.
Perfect. And it leads me to the second question. And I would kind of want to ask, because this is something I sort of asked a practitioner in the MLOps community recently, and then there were different opinions on this. Would you consider data observability a part of ML observability, or these are like two distinct concepts I should think about whenever I'm starting to think about the observability space? Are they two different concepts, or these are things I should think about holistically?
It's a great question, and I think, like, as an industry, we are still coming to conclusions about this, and it's great that there's like good discourse happening about it. To me, machine learning observability is a particular application of data observability, which means that when you solve for machine learning observability, you more holistically solve for data observability as well. And what I mean by that is, like, when you're monitoring a machine learning model, what you're really monitoring is data, right? Again, input data, maybe the whole data pipeline upstream of the model, but fundamentally data, and then the output data, the predictions being made, and then ground truth or performance data. These are all data, right? These are just very specialized data that have particular schema, they have particular relationships, right? Like, this is different than just data in a data pipeline, because there's a crucial last step in it, which is this machine learning model that has some fundamentally different capabilities and, some particular attributes that make it different. So I would say, like, solving for ML observability solves more broadly for data observability, but the opposite is not necessarily the case. That, like, solving for data observability doesn't necessarily mean that you are picking up on the important things about a machine learning model, like, the F1 score.
Right. And still on that particular topic of model training, I'm kind of thinking, usually when and I'm thinking in the aspect of the angle of a use case where, in most cases, even if we are solving a supervised learning problem and then we are trying to monitor our supervised learning use case, there are most cases where the ground truth will be delayed and will not receive the ground truth properly to properly estimate the model performance and things like that. How does observability cover for that particular scenario where the ground truth is delayed by a day or two, or probably even 1 month? For example, say a loan classification problem. How does like observability cover for such particular scenario in terms of estimating that performance and not having to wait for the ground truth to be available to do that?
Yeah, great question. So I think there are three different answers to this question. One is about estimating performance, one is about waiting for actual ground truth, and the last is about using the data that you have available. So I'm going to walk through these one by one. So the first is estimating performance, and I really like talking about this one because it's the most bleeding edge. It's the thing that, like, we're still very actively developing as an industry. So there are a number of different algorithms that you can use when you don't have ground truth in order to estimate the performance of a machine learning model. The one that I think has the most academic rigor behind it and looks the most interesting is one called Mandolin. So what Mandolin does is it basically slices and dices your data in a bunch of different ways, and then allows you to create estimates of, if I see my data drifting in this feature by this much, this probably has this kind of impact on my machine learning model. Again, this is only an estimate, but it's cool that it allows you to know, even though it's just an estimate, this is how much my machine learning model is likely degraded in performance, even without direct access to these immediate ground truths. The second option, or the second answer to the question, rather, because actually you do all three of these things in parallel, not one or the other or the other. The second is you accept your delayed ground truth. So a lot of machine learning systems are incapable of taking in, machine learning monitoring and observability systems are incapable of taking in delayed ground truth. But I actually think it's very valuable because all ground truth has a certain level of delay, right? Like when you order an Uber, I'll come back to this example, the ETA prediction is made some amount of time before the trip is completed. And it's short, right? It's not days or months, as in your example. It's probably on the order of like minutes or at most hours, but it's still some amount of delay. So when constructing or choosing a machine learning observability system, I think it's really important to create or to use one that takes into account the fact that your ground truth is going to come in late and is still going to be able to like pedal that ground truth back propagate that ground truth to the observability system so that you can view it. Okay, these are like the two most concrete. The last is basically, even if you don't have access to the ground truth itself, you can very often pick up on performance degradation just by monitoring for data drift in the input data and changes in the predictions being made, right? Like if there are fundamental changes in the way that people are using a product or in the way that the real world is generating data, then likely this is having some effect on your model and whether it's stale or not, right? It's hard to quantify. We need to use something like Mandolin to be able to estimate that, but at least we know that if there are changes, those changes are likely impacting the performance of our model.
Right. We've spoken a lot about these algorithms, and then there's a good follow-up question from a team from Reddit. And this team is asks, hey, we are getting familiar with monitoring in our ML system, and we are just curious, in our ML team, and we are curious, what's the level of math and statistics required to get monitoring right for our projects? So we've spoken about data drift, and, I believe there's some level of math or stats you need to be able to know before you are able to estimate those properly or detect those. What's the level of math and stats required to get this up and running?
Yeah, great question. Really valuable question. I think the answer is it depends on the type of solution that you're choosing, right? Like if you choose an out-of-the-box tool, right, like something like Y Labs or one of these vendors that provides a solution, level of math is like arithmetic, right? Like you need to be able to look at numbers and say like this number is increasing or like this number is decreasing. You need to be able to like look at a chart and understand what the chart is saying. If you're implementing this yourself, I would say you need like maybe the equivalent of like an undergrad statistics understanding, right? Like you need to understand what a distribution is, right? You need to understand like, here's what a histogram is, here's what it represents underneath. You don't need to learn like you don't need to know what a Poisson distribution is. You just need to know what a histogram represents. And then you need to be able to understand the concept of distance metrics between two distributions, right? And there's a bunch of different distance metrics that you can use. Again, we use Hellinger distance, and I can dive into why Hellinger distance is cool, but there's also like KL divergence and a bunch of other metrics that you can use to basically calculate what the difference is between two distributions. But none of this is like pure math or set theory or even calculus, right? This is all statistics, probability theory that you can learn in your undergrad statistics. Yeah.
We have another question from the MLOps community, and this person is asking, coming from a software background, you probably know there are lots of granularity, with monitoring. I think we've mentioned something like this, but how do you suggest this person works? This person is asking, anyways, how do you suggest I work on capturing the big picture, while not missing the relevant details when it comes to like monitoring my ML system? And have you seen tools that take care of this, or do I have to figure it out myself?
Yeah, starting with the second question first. Yes, I have seen tools like this. I, helped build one.
Right.
Yeah, there's ML observability tools that really like lose the forest for the trees and focus on trying to surface as many metrics and as many like graphs and visualizations and basically like barrage you with information with the hopes that you'll spend the time to like pick it apart and figure out the right most relevant piece of information. I would say that like Y Labs and probably most of the other mature vendors in the ML monitoring and observability space do a good job of being opinionated in, selecting the most relevant pieces of information and giving you like really high level views of model health and model performance health so that you can dive in and debug at the place when it's appropriate rather than giving you a ton of false negatives, right? A ton of like wrong alerts. I can't speak for most other tools in the space because most of them are closed source and don't have it's not possible to interact with their platform without talking to a salesperson. I can say that like at Y Labs, in addition to trying to minimize false negatives, we also try to minimize false positives, and we try to give people the ability to like tune the model that we use to send out alerts and notifications so that you can really get the right percentage of alerts for you. Okay, and then to the non-vendor, like tooling part of the question, which is like, what are the key things to really be looking for? I would say that like, again, if you have access to ground truth, the absolute best thing that you can know about your model is how is my model performing? Like literally, is it making good or bad predictions, right? If you have this, you have like 70% of the value of a machine learning observability or monitoring system. When you don't have access to ground truth, this gets harder, and you need to be able to monitor data drift and the output and all of that. I would say and that's just for monitoring. If you really want like observability, just model performance is not going to be enough, right? If we go back to the definition of like observability versus monitoring that I gave earlier, monitoring tells you that something is wrong. My model is not performing well. That's something wrong. Okay. But now in order to be able to debug it, I do actually need observability across the entire system. And I need to be able to dive into the parts of the system that are really causing the problems. So, while monitoring, you can really just look at performance if you have access to direct performance. For observability, you do need to see the entire system start to finish.
And leads me to the next question. What are the common mistakes you see teams making when starting out implementing like ML observability for solutions, for their projects?
Okay, like level 0 problem is just not doing it, right? Like inertia, not recognizing this as a problem that they need to solve, not being given a lot of the time. It's like, they would like to be able to do this. It's just they work at a company and have constrained resources and aren't able to, put into place these safe ML practices. So that's like the level 0 is doing nothing. The level 1 mistake, I would say, is using tools that are not built for MLOps, right? Like thinking that you can solve for ML monitoring by using traditional DevOps monitoring tools, like a New Relic or like a Datadog or like Grafana and Prometheus. These are all very, very powerful tools. They do their jobs really, really well. Their jobs are solving software 1.0 application performance monitoring and observability, right? Their jobs are letting you know, like, is my application down? Is it working? What kind of SLAs am I hitting? All of these things. Again, like as I talked about earlier, this is distinct, or rather it's, a subset of the problems that we face for machine learning models. So I would say the level 1 mistake that people make is trying to kind of shoehorn their existing tooling stack. Beyond that, there's like smaller mistakes that people make. I would say one is like not monitoring the entire and not getting observability into the entire ML system. Again, like to really debug a problem, you need to see the entire pipeline. You can't just look at the model at the end. That's a common mistake. But I would say, if you've gotten past the previous problems, you're like already in a better place than like 95% of the industry.
Awesome. And I think you've spoken about levels, and I would love you to walk us through what does it mean to start observability from like say level 0. I don't want to use any tool. I just want to start thinking about observability, and then how do I graduate from not using tooling, which we've not really to kind of using like tools, and then maybe all these other vendors, and how would you suggest I go through that journey from just starting out thinking I don't want to use any tooling. I just want to monitor my system, the barest way, and then graduate towards that. How would you suggest teams do this?
Yeah, absolutely. So I guess like the way to really get like the easiest version of monitoring done is just like calculate and store these things somewhere and visualize them with something. Like, and the way that you do that is entirely dependent on your process. Let's just like take for granted that somebody's running in a Python environment. Okay, just like have a pandas data frame where you're appending new rows that are being input into your model and predictions that are coming out of your model. And then if you have access to ground truth, save that too. And then you have this pandas data frame. Maybe you're like continuously saving it as a CSV. Maybe you're using like a SQLite database. The point is that like a monitoring system needs to have some kind of data store. And then it also needs to have some kind of visualization, right? So you need to be able to take the data that's in your pandas data frame or in your SQLite database or whatever, and then visualize it with like Matplotlib or Seaborn or Plotly, one of these tools that helps you to visualize data. And I would honestly say that like this is already like a really good step towards monitoring an ML system. It's immature. It takes some amount of like tooling and setup to do yourself, right? But it's nothing crazy, right? Like we could code this up in Python pretty easily.
Yeah, we have a question in chat from Wilson, who is saying he would love to hear your thoughts on why Hellinger distance is your preferred choice for measuring distribution drift. He adds that the way he would typically do this is to use Wasserstein earth movers distance. So he's wondering if he should consider Hellinger distance instead going forward.
Totally. I'm not an expert on distance metrics. Like I studied them a little bit in my undergrad, but definitely I'm not familiar with every possibility out there. I would say the reason that we use Hellinger distance and find that it works really well for our customers is because the metric is symmetric. So like it's normalized to be between 0 and 1, which is really convenient for monitoring. And it also has the nice property of being symmetrical. It handles missing values really well, which is really powerful. Maybe Wasserstein Earth Mover distance does too. I'm not sure. But like I think this is also really powerful, the ability to take into account missing values. KL to KL divergence doesn't have symmetry, which makes dealing with missing values kind of harder. But I'm not sure whether Earth Mover distance has the same problem. And then the last thing is like Hellinger distance is easy both to calculate. Like there's both out of the box tools and it's like arithmetically, it doesn't take a lot of math under the hood. Like your computer is not doing a lot, so it's very computationally efficient to calculate, but it's also very easy to interpret. Like because it's normalized to be between 0 and 1, it's really easy to understand this is how much my model or this is how much my data has drifted, and really be able to like visualize and and be able to like compare, changes in data over time to see when there's a big discontinuity and a big potential problem. These properties might be there for Wasserstein Earth Mover distance too. I don't know, but this is why we use Hellinger.
Great, thanks very much, and thanks Wilson for the question. We do have another question as well from Nana. Nana, go ahead.
For most of them distance metrics, it looks like the length of, let's say if you want to compare a feature which was in your training or tested to the post-production data set. So the length have to be equal for the distance metric to work. Am I correct? And if so, what happens if like the length of, let's say, the feature in the training set is not the same as that of the test? What kind of other metrics would be available to compare them?
So again, like I'm most familiar with Hellinger distance now because it's the one that I'm interacting with the most. With Hellinger distance, they do not need to be the same length. Like you calculate the distance between these two distributions, but that doesn't require comparing like one-to-one the values across the two columns. I can't speak to other distribution or to other distance metrics and how they calculate in the case of different lengths.
Awesome. I think we can come back to away from the stats, of course, to some more very practical things. Like I think the testing side of things, right? How crucial are these? Like when you're thinking about observability, you're running things like your data checks, you're running things like your model tests and things like that. How crucial are these processes to the entire observability process?
Great question. So I think checks to me are super useful. I wouldn't classify them within observability necessarily, although I think that they help to solve very similar problems to monitoring. So like, for instance, when I think about, the ability to put constraints on your data, which is a feature that YLogs has as an open source tool, or like Pandera similarly allows you to put constraints on top of your data. Or, you can also create these constraints yourself, in Python by just saying like, if data exceeds 1, break and send an error, right? Like you can do this stuff out of the box as well. These types of constraints, as an example of a data check, are really useful in alerting you and in like preventing potential data quality degradation or other types of data changes that might be detrimental to your system. But they don't tell you, like observability, again, is the ability to understand what's wrong in order to debug it, in order to do root cause analysis. These don't tell you what's wrong so much as surface to you that something is wrong. And it's a different approach than like the continuous monitoring approach, where it doesn't like break, it just gives you a notification, because these are constraints that will like stop a system from running if there's some kind of problem that comes up, which is a useful feature very often, but is different than the continuous monitoring approach, where you allow a system to run, but that there's something wrong so that you can go and fix it.
Right. So for the continuous monitoring to work, I used to think that like you need to have those checks in place to tell you, okay, look, there's a breakage or there's a leakage in your data set or something like that, or teams don't have to do that to be able to monitor the system. Is that called monitoring in any sense?
Yeah, I would say that the checks are like useful, but neither sufficient nor necessary for monitoring. Right. Like really, I would say what monitoring fundamentally requires, and observability too, they both require logging more than anything else. They require having telemetry artifacts that you can use to understand the state of a system as it changes over time, right? Observability is understanding the interior of a system based on its outputs. So you need to be creating outputs. You need to be creating like the artifacts about the telemetry artifacts about a machine learning system. And that's via the process of logging.
Perfect. Thanks for answering that. So there's a question from the community again that was sent to us before now. And this person is asking, could you walk me through how I can think about implementing monitoring for a session-based recommender system? Do I need to think about performance measures and then monitor for that? Or is there some holistic thing I should, monitor for?
Yeah, great question. I would say that like monitoring and observability space is really mostly focused on classification and regression, and that we're still very much developing the best practices around recommendation systems. That being said, like there are some fundamental similarities and some best practices that we can very trivially apply from classification to or classification/regression to recommendation. Like changes in the data distribution of input data indicates some kind of covariate shift in the real world, which indicates that your model is very likely stale, right? Like the canonical example of this to me is Netflix. And Netflix is one of the biggest recommendation engines ever. It's really, really powerful. And it also experienced huge data drift because of COVID, right? Like people all of a sudden started watching way more Netflix. To the point that Netflix like gave people money back if they weren't using their Netflix account often because they were pulling in so much money. People were watching way more Netflix, and people's habits on Netflix, the type of shows that they wanted to watch, changed. Right. So this this big shift was very obvious to anybody. It's like, yeah, of course, like anybody can tell that people are using Netflix more and differently than they were before. The more insidious thing that happens is when you don't have like, a global pandemic, but very slow societal changes that end up impacting the way that people use a product and people's preferences, right? When those types of insidious changes happen, you need to be able to continuously monitor in order to understand those changes. And so that's like the data drift equivalent in a recommendation system. You can also think about how you're calculating performance within recommendation systems, right? I'm not an expert on RecSys systems. I primarily have dealt with regression and classification whenever I've done my modeling, but there are similar concepts of model performance and of being able to tell if a model has gotten stale or if a model is still able to perform well by, inferring whether people are following the recommendations that you give them, whether they're like actually enjoying the content that you're recommending for them in the case of Netflix or whatever. So you can still like similarly apply best practices from classification and regression, including stuff like data drift and like performance monitoring, to recommendation systems.
So what are the best practices to monitor the data drift in a real-time streaming data for a forecasting use case?
This is a great question, and one that I think is like really under talked about because it requires getting kind of a level deeper than people normally get into. So when we think about real-time monitoring makes a lot of sense for like a software 1.0 system, right? I want to know in real time, how is my system performing? Is it giving people responses so that I can respond in real time or even have automated responses in real time? But what would it mean to monitor for data drift in real time, right? Data drift is not something that happens like from one individual prediction, right? We can monitor for like for specific variable changes, for having all of a sudden there's a bunch of rows that have a bunch of nulls in them or like a bunch of zeros in them. But data drift is about comparing distribution to distribution rather than data point to data point. And in order to have a distribution, you need to have more than one data point. So you need to pick a certain level of granularity that you're going to be comparing against. And you need to be able to compare against multiple levels of granularity. So this is a little bit abstract. Let's get a little bit more concrete. So we've got streaming data coming in. Now I can either batch that data into hourly and compare this hour versus the previous hour, or I can look at today versus yesterday. And a really good ML monitoring and observability system will allow you to change that granularity and to compare against any level of granularity, be it daily or hourly or even like weekly or monthly. But it's important to keep in mind that if anybody tells you that they're doing real-time data drift monitoring, they're not being entirely accurate, because it's impossible to monitor data point by data point for data drift. Because data drift doesn't happen on the data point level, right? You have a lot of noise on the data point level. It happens on the distribution level. So you need to be able to aggregate multiple data points into a distribution in order to do that kind of monitoring. Now, that's for data drift in particular. Data quality monitoring is a really great use case for real-time data. And we actually have real-time data streaming capabilities built into ylogs, where we can take in Apache Kafka or other types of data streams and generate logs based off of those in order to monitor for data quality in real time. But for data drift, that's something that can only happen at a batch level, because you need to be able to compare multiple time windows against each other. Really good question. And that's a level of depth that's like really fun to get into, because most of the time the conversation is just me saying you need to be monitoring your machine learning system over and over again.
Awesome. And thanks, Danny, for answering the question. And there's one thing that I think that I don't quite get clear, and I hope I know for sure that it's the same for a lot of people, and that's monitoring for like edge devices. So I deploy something on the edge. How do I start thinking about observability on the edge versus when, say, I deploy to maybe like a cloud endpoint, and then it's easier from there. But with the edge, I don't quite know how to go about both the observability as well as even managing my model on the edge itself. So what's your opinion on that?
Stephen, I feel like you're like going through the YLabs website and you're like picking things that will help me sell my product. And I really don't want to be talking about YLabs all the time.
Yeah, sure. I mean, yeah.
but there's been this blog post kind of brewing in my head about the fact that YLabs is the only observability system that will work on the edge, because we're the only monitoring and observability platform that separates the logging component from the monitoring and observability component, right? Like if you think about trying to deploy a full monitoring platform on an edge device, it's impossible. Like, not only does it take a bunch of compute and a bunch of resources to run a full platform, it also, will be difficult to access because it'll be on device instead of being, on the cloud or on your laptop. Conversely, by putting a logging tool like ylogs on the device, you can stream back the logs in in real time or in batches, depending on what the device's level of connectivity is. You can take logs off of the device and move them onto a platform running like SaaS in the cloud, like Y Labs, or running locally on-prem or in some other environment. And you can bring these logs back to that platform and be able to monitor either across all of the devices and aggregate the data from all of the different devices, or you'd be able to take those logs and look at individual devices themselves instead of looking at the system in aggregate. So this is really cool and something that's really only feasible with logging, right? Because if we were dealing with trying to monitor raw data, get really expensive to be sending, and probably privacy violating and a lot of other problems, trying to send this raw data off of device and onto our platform. But if we use logging techniques, then we can send logs rather than raw data.
That's awesome. So without tooling, how can you take this on without tooling?
I guess the solution to do this without Y logs or Y labs would be to like build a logging tool yourself. And like the really easy way, the really like simple way to do this would be to set like in your device, basically at the end of every day, you collect all of the data that you've inferred on from that day, and you generate some kind of summary statistics on that data, and then you send those summary statistics back to your platform, right? Because those summary statistics are both privacy preserving, so you're not potentially violating user privacy from their device data, as well as being a lot more lightweight than sending back raw data. But I would say there's already an open source library that does this really well, using a bunch of really cool math techniques to really efficiently extract a lot of these summary statistics, including like the entire distribution rather than just the mean and the median. So yeah, I would say you could implement this yourself, or there's a cool open source tool that does this.
Yeah, fair enough. Thank you for sharing that. And back to practicality again. There's this particular question that came from Reddit, and this person is deploying an NLP use case. They have like an NLP sort of model in production, and they're sort of thinking about ways they can start implementing observability for that model. So where should they start from? Are there levels they should go through? I mean, you've spoken about something like this, but maybe being more specific about this use case might help this team.
Totally. I love talking about complex and unstructured data. I think it's a really interesting scenario that really like doesn't get covered enough in monitoring and observability. Actually, myself and two of my colleagues from Y Labs, and potentially from one of the companies that we're associated with, will be giving an hour-long talk about specifically monitoring unstructured data or complex data types at an event by the AI Infrastructure Alliance, or AIA, in I want to say in a couple weeks. I think it's in like late June potentially. So we'll dive. We'll spend an hour talking about this at that event. Feel free to reach out to me if you want a link or an invitation to it. But the like short answer is basically whenever people talk about monitoring unstructured data, it's actually impossible to monitor unstructured data itself, right? Like when we think about comparing distributions, this makes sense. I can take my distribution of my numeric variables and see how that distribution changes over time. But what would it mean to talk about how like language usage or text changes over time? Well, you couldn't talk about the text itself, but you can extract features or metrics out of that text and then use those and monitor changes in those. So we can say like, one very common, very simple metric is token length. So like how long is every word within this this document, right? And see changes over the corpus, like in the corpus over time, to see that words are getting longer or words are getting shorter. And this indicates some kind of changes in what's going on. That's like a very simple metric. There's more complex metrics too, right? You can see like changes in reading level. That's a type of metric that you can calculate on NLP data. Changes in sentiment. You can see like, are people getting happier or angrier? Are people using different languages? Are they using different parts of the Unicode blocks? Or, are they, switching from using English to Cyrillic or, Roman characters to Japanese characters? Are they all of a sudden using emojis or something like this, right? You can track changes like this. And one of the really cool things about the NLP space is the huge diversity of use cases that are out there for NLP, and the fact that there is no one perfect metric or even a collection of metrics that are perfect for monitoring for every use case, which is why it's really important to find the metrics that are most important for you and be able to use a tool that lets you monitor those metrics, be it, token length or sentiment or reading level or, where things are coming in the Unicode block, or even like other metrics that I don't know about and don't even think about because I'm not an NLP expert.
Awesome. Thanks for pointing that out. I would love to come back to one crucial topic in the AI ethics space. Now, we hear a lot of things about explainability. So where's the fine line between observability and explainability? And, are they things that teams should think about consecutively? Maybe once I think about observability, think about explainability, or I should think about them simultaneously. How should I approach it as a small team, deploying like a handful of models in production?
Yeah, totally. So I'm gonna give a really hot take on this. This is something that's gonna get me in trouble with other people in this space. I think that people completely mischaracterize the value of explainability and where we should be using explainability in our tool set. Like even at this IA event, it's about monitoring observability and explainability. I actually think explainability is a little bit of like the odd one out in that trio. Because monitoring and observability are really something that you do once your model is deployed to production to make sure that it's able to still perform well in production. Explainability, most of the time, is something that you actually want to be doing while you're developing your model. Like explainability, what it comes down to at the end of the day is usually feature importance. It's either global or local feature importance. It's the other, in general, what is my model using to make its predictions? Or in this specific scenario, what did my model use to make these predictions? And that can be useful. It absolutely can be useful at the explainability, at the monitoring and observability stage, because it can help you kind of debug or prioritize certain types of alerts. Like if I've got data drift on a very highly predictive feature, that matters a lot more than if I have data drift on a feature without a ton of predictive value. But I would say that most of the value of explainability really comes when you're still developing your model and are trying to understand, what features should I be engineering more? What features do I need to be enriching more? What's making this model work or not work? And then I also want to talk about something else. And this is another rant that's going to get me in trouble with the MLOps community. But I have a whole presentation and a blog post that I've been writing about this that I'll be delivering later this year. So I think people clump together explainability and fairness way too often. Fairness has a lot more to it than just understanding which features a model uses, right? Like a credit score, right? We know exactly which features a credit score uses. But do we know whether credit scores are fair? Do we know whether they're potentially discriminating against marginalized groups, be they, racial groups in the US or gender groups or religious groups, right? Do we know whether these models are fair? That's a different question than knowing which features does this model use. Because it's very rare that somebody is going to explicitly encode something like race or gender or religion or class or ability within their model, right? Most of the time, none of us want to do something like that. But we can still use other features that are really highly correlated with these protected classes or these marginalized groups, and which therefore cause disparate impact on them. Again, this is a whole rabbit hole that deserves more than a 5-minute answer to a question. And I'm going to be giving a talk about it later. If people are interested in diving into this more, please feel free to reach out to me. This is a conversation that's very actively developing. But to me, I think much more so than explainability, the key tool to being able to ensure fairness is actually segmentation. You need to be able to segment according to a protected class in order to know whether your model is discriminating against that protected class.
Yeah, fair point. Thank you so much for answering that. And I think this is probably one of the final questions, and that's it. What's the unsolved problem in ML observability right now that you think that it's still very far from solving?
The unsolved problem is, how do we get everybody to do this? I mean, there are some interesting like specific features and like specific problem sets that we're working on. But in terms of like improving the reliability, in terms of improving the robustness of machine learning systems in production, the thing that will the thing that will make most models better is not like, the most bleeding edge observability or monitoring technique. It's literally doing any amount of observability and monitoring, right? It's like in healthcare, right? If you want to save the most lives, you don't need to solve, for some really niche, really advanced cancer drug. What you need to solve for is like malaria or HIV, right? These like really prevalent, really pronounced diseases. And I would say that the equivalent in ML monitoring and observability is not like individual particular features, but more getting everybody on board with these best practices of making sure that you are monitoring and getting observability. So long answer short, the big unsolved problem is getting everybody to do it.
Right. Awesome. And I think on the final notes, are there best practices you want to put out? You've put out a lot of best practices today. Maybe we need to end on a good note, right? On a take-home note, I would say. So what are those things you would want teams to look out for? Because again, this podcast is mostly focused on reasonable scale teams. These are teams that are a few number of engineers, data scientists, but they want to do stuff that works for them, right? They don't want to take up stuff from Google or Amazon, those techniques. They want to do stuff that works for them. So what are some take-home practices you recommend for such teams?
Observability and monitoring. Definitely do it. Right. Make sure that you're doing this not just at the machine learning model, but all throughout the data pipeline. Make sure it's complete. And this is a little bit self-serving, but like make sure that you're logging your data, right? Like one of the worst things that I see is I talk to teams and they're like, I actually don't even know where those predictions went. I actually have no idea where this data gets stored after we're done with it. It's like, well, like how are you going to debug a problem if you don't have access to historical state, if you don't know what's going on? So I would say like doing these three things is going to put you at like the 90th percentile of MLOps, of MLOps companies. And it takes some amount of effort, but it's like the 80-20 rule in effect. Like you can get 80% of the value by doing 20% of the work.
So we've come full circle to the DevOps, the DevOps pillars of observability right now. Cool stuff. Thanks, Danny.
All right, great discussion. Before we wrap it up, Danny, could you tell us where can we find you and connect with you?
Yeah, so right now I'm in Mendoza, Argentina. So if you guys want to come and drink some wine with me, we can do that here. If you want to contact me, remotely or digitally, my LinkedIn, I'm really active on my LinkedIn. My email is danny@ylabs.ai. And I'm really responsive over email. And lastly, there's a Slack community that the Y Labs team is growing for MLOps practitioners called the Robust and Responsible AI Community, or R squared. So you can join that Slack community and I'll answer your questions there. Our engineers, machine learning engineers, data engineers, data scientists will all be there to answer any kind of questions that you may have.
Wow, good stuff. It was very good to have you, Danny. Great discussion. Thanks for sharing your insight and providing really helpful and clear answers to the questions. So we'll be back again in 2 weeks as usual on the 8th of June. And next time we'll have Fernando Barrera and Jakub Zavrel with us. And the topic will be data engineering and MLOps for neural search. So don't miss that one. Submit your questions in advance if you want on socials or in the MLOps community Slack, wherever you can get in touch with us, and catch up with previous episodes on Apple Podcasts, Spotify, whatever you use. Thanks so much again, everyone, for joining. Take care. See you next time. Bye-bye.
Thank you for the great question. Yeah. Hi, everyone. Thanks, Steven.
MLOps Live is brought to you by Neptune AI. Remember that you can join us live at the next event and ask your questions. We run it every other Wednesday, and you can register at neptune.ai/events.
And then make sure to search for MLOps Live in Apple Podcasts, Spotify, Google Podcasts, and anywhere you get your podcast. Click follow and don't miss any episodes.
Thanks, and see you next time.